Hi, everyone. Welcome to the Postgres Conference 2024 talk on Postgres extensions. So what are Postgres extensions? You have the core Postgres kernel, which is lean and mean and excellent at transaction processing, running queries, etc. Any kind of additional functionality you need, which is not part of the core Postgres kernel, you would use the extensions that Postgres provides to get additional functionality. Similar to like languages like Python. They say batteries included, right? So you have the core Python and any other functions that you need, you keep adding the modules to Python for additional functionality. I am Rajiv Totatil, Database Specialist Solution Architect with AWS.
I'm Anita Singh. I'm also a Database Specialist Solutions Architect with AWS. We are peers, and we help customers modernize and migrate their databases to AWS.
Okay, we'll jump right in. So, most probably all of you have worked with relational databases for a while. You have databases like Oracle, SQL Server. Postgres by nature is designed to be easily extensible. Okay, there are some extensions which are included with the Postgres core. So when you install it from the Postgres source, you will have a directory where you have some of the included Postgres extensions. The others you can download, possibly from GitHub. You can compile them and add them to Postgres. It supports things like installing, uninstalling, updating to a new versions, etc. And for some of these extensions, you don't need to add anything to shared preload libraries for it to work. And for some of them, you do need to add it to shared preload libraries before you can actually create them and use them. So what are these extensions created with? For the most part, there is a control file where you have some config information like extension name, extension version, etc. You always will have a .SQL file which creates different objects within the database. It might create PL/PG/SQL packages, etc., configuration parameters. So there'll be a .SQL file. And then you'll have your object files. If you're writing it in C, you'll have an object file which actually does the functionality of the extension. So why are some of them required to be loaded via shared preload libraries and some not, right? The reason being there are some of these which actually needs to allocate shared memory, which needs to take some lightweight locks, etc. So such things you will need it to be loaded when Postgres or the Postman process actually starts up for it to work. Some of them don't. Some of them just simply have a .SQL file and some associated PL/PG/SQL, etc. Right? So that's how you get the extensions to work. There is a lot of extensions that are supported with PostgreSQL. This is just a full list, not a full list, a partial list of some of the popular ones. And especially if you're running Postgres in some of the managed services, like in AWS, you got to be a little bit careful because there is a curated set of extensions which are supported. Not everything is supported with some of these managed services. So this is a broad spectrum of topics under which extensions fall under. There are performance-related ones, there are administration ones, there are extensions which allow you to access disparate data sources like the foreign data wrappers, etc. There are replication-related ones like PG-logical, there is AI machine learning-related ones, there is text ones, there is geolocation-related ones, monitoring and logging like PG audit, and there are additional indexes you can create for different data types and different functionality using extensions. In this talk, we are just going to talk about performance and admin-related ones. There is another talk on extensions and data dictionary views, which is right following this one, which will go into extent about all of those other extensions. So under the performance extensions, I'm primarily going to cover these three things: PG-stat statements, PG-hinplan, and PL profiler. So what's PG-stat statements? Anytime you're interacting with a database, you are running SQL statements. PG-stat statements is the extension which allows you to track the execution of these SQL statements. It gives you a lot of statistics regarding the statement execution. For example, it has per SQL statement, it can give you statistics like how much was the plan time, what was the average plan time, what was the maximum plan time, How many times did it execute? When did it execute first? What is the average and max times for executions? How many rows did it actually return? All that kind of information can be gotten from pgstat statement. So keep this in mind. Everything keys off a query ID in pgstat statements. We take the statements, it normalizes, when I say we, I mean Postgres. It takes the statement, it normalizes it. So for example, if you have the same statement with different bind variables or different literals in the SQL statement, it kind of replaces it with question marks and then gives it a query ID, right? So you can keep track of all of your statement executions, how much time it took, how many rows it touched, etc. from here. So if you want to find your top executing SQL statements, you can look at the elapsed times of these queries, you can aggregate them and come up with your top 10 SQL statement, etc. So here is a sample query you can run against pgstat statements. This gives you per statement what the buffer cache hit ratios is. Buffer cache hit ratio is very important. You want it to be 99% to get good performance with relational databases, simply because this data is coming out of the memory, your shared buffers for the most part, if you have high hit ratios. So this is a statement you can run off pgstat statements to actually see what the buffer cache hit ratios are. So there is shared blocks hit and shared blocks read in pgstat statements. Blocks hit came from memory, blocks hit had to go to disk to get those pages that it needed. So you take the ratio between block hits and the sum of blocks hit plus read, and that gives you your hit ratio, right? So easy enough statement to run to identify statements, and if you order it by the total time descending and limit to 3, you get the top 3 statements which have the highest, sorry, going by descending, this gives you the ones which has the least hit ratios. So a lot of times it's semi-useful, and a lot of times you also want to actually track the SQL execution over time. That's not something that view gives you. It's an aggregate from when the instance started up, right? So there are also utilities you can find on the web which actually snapshots this information and lets you track SQL performance over time, etc. So you can do various things with that view. So let's talk about PG hint plan next. Anytime you're looking at SQL statement performance, you are looking at the execution plan, and there are 3 key things that you look at in the execution plan. What are the join orders of these tables? What are the access methods of these tables? And the join methods of these tables, right? So you want to know which tables got read first. How did they join to other tables? What was the table access method? Was it a sequential scan? Was it an index scan, etc.? And we heard the talk from the morning where they were talking about the statistics and the cost-based optimizer, etc. Once you start joining multiple tables, it's quite hard to control how these plans are created. So PG hint plan basically gives you a way to enforce a plan for a specific SQL statement. So so you can add hints like here, like the leading hint, so that T2 is read first and then join with T1. And then you can look at the execution plan and you can see PG hint plan actually pick up those statements. So it's a way of providing hints to SQL statements so that you can force an execution plan on a statement. This is good and bad. Good in the sense that you can get a plan you want, which is optimal for your particular data. However, it could also, once your data volumes grow, it might not end up being the best plan for that statement. So you got to be careful as you use PG hint plan. So you have to be mindful of the table data size changes. If you change SQL statements, that same SQL statement, if you change like the table name or something like that, it might not, the hint might not work. And anytime you do major version upgrades, it might change the functionality and it might not, the hints might not work as you intended it to, okay? It's also really cool. If you don't want to go change your application, there's actually a table. There's a hints table that you can put the query ID and the hints you want, and it'll use it with the statement. So you can even go behind the scenes and have it change your execution plan. PL profiler. Anytime you are looking at pgstat statements, what you kind of get is the top level statement. And for a PL/PG SQL procedure that you're executing, it's the function name. So you can get the execution times of the function, but you really do not know which statements within the PL/PG SQL function or procedure is taking a lot of time. So that's where PL profiler helps. To install it, you create the extension. It actually has to be downloaded from GitHub and installed and configured. And then you have to install PL Profiler, which is a command line tool. And then you execute your SQL statement, and it can create an output HTML file. The HTML, here in this example, the PLPG SQL you're executing is inventory in stock, and you're giving it an argument. So that has a bunch of SQL statements in there. And it'll produce this HTML output, which clearly tells you which statement within that PLPG SQL actually consumed the most time, right? So this is a good way of saying where exactly in your stored procedures it's spending the time. So it's a pretty good extension for performance-related profile.
All right. I think I got it. Oh, clicker. Thank you. All right. Thanks, Rajiv. So next, we are looking at some of the most popular extensions when it comes to doing administration tasks. And we'll be looking at these four, pgpartman and pgcron. They work together to make partitioning easy job, pgprewarm and pgrepack. So let's get started with the first one, that is pgpartman. So most of you might be aware that partitioning is one of the strategies we use when it comes to handling large amount of data. And PG, by default, when you create a partition table, you create a, without pgpartman, it's quite tedious to go through the process. You create a parent table, and then you have to keep on creating child tables going forward. And depending on how do you partition them, you might have to create hundreds of child tables. So that becomes quite tedious. And that's where pgpartman comes in handy. So pgpartman, it has a capability that you can define multiple things, not only the creation of the child table, but also maintenance of those child partitions. You might want to back it up for older partitions. You might want to drop the older partitions. So just by defining the parent, you have the option to mention, like on this example, we have the events table, which is being partitioned by event date type. And we want the monthly partitions to be created. And we are asking it to pre-create 7 partitions, starting with January 1st, 2024. Now, after we created, we had a business requirement that we want to change the retention to 12 months. So we mentioned that. And otherwise, infinite time partition is equal to true. But once you have this setting, it will manage it, but you do have to go in and run the maintenance procedure manually, run maintenance proc. And what, like I mentioned, this gives you multiple options. You can create a backup table, and that's where you want the older data to be migrated or moved, or you want it to be dropping the old partitions. It can handle it all just by defining this. So pgpartman, like I said, you would have to manually execute the maintenance job. Instead, there is a scheduler. Most of you might be knowing the cron scheduler, which is very familiar when I think whenever we want to run any processes on a routine basis or any jobs, we use the cron tab in Unix. But here we have this pgcron. That is another extension. It's a very lightweight job scheduler. It gives you the capability to run any routine job at the interval that you desire. So this works hand in hand with pgpartman. Here you can see that I have this particular table. I'm defining the retention to be 3 months, and I do want to retain it. So I have retention keep table. So once we have this defined, we can use the cron, pgcron extension to schedule that maintenance job to be run hourly. You can go as granular as you like. So both these come together to make the partitioning easier job. The next we look at pgprewarm. So pgprewarm has 2 capabilities. Mainly it is for warming up the cache. You might have a need where you want to warm the cache so that some queries perform better. Otherwise, it like for a query to run, if the data is not in the cache, it has to go and pull the data from the disk, which is a slow process. So for many times, I think we cache the content, and that's where pgprewarm comes in handy. It has 2 options. One of the options is you can do it manually. That is, you can, shown here, you can just say select PG preform and mention the contents which you wanted to pull in cache. And the other is automated, which is useful. So if a database crashes or if it is rebooted, then at that time you lose the contents of the cache. And that's where you would put in the process of automation. You would need to configure it. Like Rajiv mentioned, it is one of those extensions which needs to be loaded in the preload libraries. So you mention it there, and after that you can set an interval at which you want Postgres to back up the cache on the disk. So there it just keeps a record of the contents of the cache on the disk. So in case your database reboots, it will, when it comes up, it will warm up the cache with the contents that were present. Now the frequency at which you want to push the contents, you can define it using this parameter. The next we have is PG repack. Now, with Postgres, we all know the nuances with the MVCC, right? We do have times when you have to reorg the table. Maybe some table has been purged, you have purged a lot of data using delete statements, and you don't expect data to come in at that time. You might want to reorg the table to get the disk space back. PG preform is kind of a replacement for vacuum full, but this is an online operation. So you can run it online. It does pretty much the same job, but it is, all right. I can't get out of. Anyways, so that's what PG repack does, and similar to that, I mean, that's a command how you can run it. PG repack, you just mention the database instance name, whatever instance you want it to run, and you mention the table, and it does it, right? So with that, I think I come to the end of the presentation. Thank you. These are some links, some useful links for each of the extensions that we discussed. So if you want to really go and test it out, those have a step-by-step instructions. Thank you.